Hi and welcome to part 5 in the Point Sense for Revit tutorial series. In this video we're going to look at creating a topographic surface using points selected in Revit and VirtuSurv, creating a topographic surface using results exported from a surface analysis, deforming a model element using points selected in Revit, deforming a model element using results exported from a surface analysis, and finally clearing the point sense data from the model. So if we open up Revit now, the tools we're going to be looking at today are the topo surface and the deform shape command. So the problem that we have with Revit out of the box in terms of topographic surfaces is that if we go to the Mass and Site tab in topo surface and we just quickly go to the site level just to drop in this topo surface, it will ask us to input a Z value or an elevation for every single point. So obviously from the point cloud this isn't snapping to the point cloud. So what we end up with, if we go back to the point sense tab in 3D view and hide off the point cloud, we end up with a flat surface if we haven't manually inputted the Z value. So what we can do using point sense is we can select points on an area in VirtuSurv or Revit, and we can create a topographic surface that has Z values. So if we just go to VirtuSurv and external scan it, you can see we're in an area here with a path and a small bank at the rear of the building. If we just load in the Revit toolbar and start to create some construction points and send them through to Revit up this bank, and then we'll just close it off along the bottom here, just add a few more intermediate points in. All of these points, as you can see, are getting sent straight through into Revit. The reason this is flashing between the two programs is that I'm running this on a single screen and the macro is running. So let's just go into Revit now and have a look. Just navigate around slightly here. We'll hide off the point cloud. You can see all of those construction points have been created now in Revit based on the point cloud selections in VirtuSurv. But what we can also do is, if we wanted to do this inside Revit, we can also add some construction points in here. So I'm just going to go there and drop a few more points in this path. There we are. And just hide off the point cloud to show you those. There we are, so we've got a few extra points in. So all we're going to do now is going to go to the topographic surface command, and we are going to highlight these points, and then we're going to click finish. There you are. So as you can see there, we've got a topographic surface, and because of the Z value of all of those points, we've got contours on there showing the difference in the elevation. If we want to go to the Mass and Site tab and just tweak those contours, we can. Let's say, for example, we'll change the increment down to 500 millimeters. Apply that. You can see that updates there. So the first thing I'm going to do here is just delete off this floor we used to create the model lines, and as you can see there's quite a bit of noise in the model lines that was created by some of the noise in the point cloud. So let's just have a look at how this would work first. We're just going to click topo surface and highlight all of the model lines and click finish, and this is the result we get with the noise. So you can see we've got some spikes in the data which probably we really need to get rid of or aren't acceptable. The best way to deal with this would be to clean the point cloud first before bringing it into Revit. However, we're not able to do that, so what we're going to do is I'm just going to go in, I've just speeded the video up a little bit here where I've just gone in, I'm just going to delete out all of these points or all of these lines that we don't want to include in the topo surface, so that we can get a nice smooth surface that's a reflection of how the actual surface is in real life. So once we're happy with the selection that we've got, if I go back into the topo surface now and just highlight those points again, or those lines again, and just click finish, there you can see we've now got a nice smooth surface which reflects very accurately the lie of the land at the rear of the building. Okay, so let's just try this similar process down here with the road. First of all, again, I'm just going to go in and delete this road off, or sorry, delete this floor off, and we're going to navigate to the top view. Again, I'm just going to go to topo surface and highlight all of these construction points, and then I'm going to click finish. If we just zoom in there now, you can see that's created a nice topo surface for us with the incline of the road and a slight gradient. And if we want to just go and check that, we can go and change the contours slightly, and we could tweak these maybe, or we could just change the base level to 0 and apply that, and then we're just going to change the increment to something more suitable, such as 100 for the smaller change in the Z value. You can see that there. So let's take a look now at how we could deform this shape using some selected points on the point cloud. So I'm just going to orientate this 3D view to a first floor, and I'm just going to crop this view down, this box section down, so that we can then turn on the point cloud and have a look at a limited area. So let's just navigate around that, and then I'll just go to the point sense tab and unhide the point cloud. So as you can see, there's some areas where the point cloud is below the surface and somewhere it is above, but I'll just show the process now. So I'm just going to get an XYZ construction point and just drop some random points on the ground here. So these are all snap into the point cloud, and similar to the topo surface, these all have Z values. So there we are, a few points dropped in there. So we could do that in VirtuSurv as well if we wanted to. So let's just hide off the point cloud to see what we've created. So we've got about 7 points there. So I'll just click on deform shape. First thing I do is select the floor itself, and then I'm just going to go around and select these 7 points. There we are. And then I'm just going to go and click finish. That's going to give me an error saying it's going to kill the surface analysis results. That's fine. And we're just going to orientate around that to see, you can see it's changed the profile of the actual floor itself based on those points, or the Z value of those points. Okay, so we're just going to have a look now at what we can do with the deform shape tool using some of the results we exported from the surface analysis tool. So the best thing to do now will probably be to bring that surface analysis back in, so we can have a look at what we were dealing with or what we're trying to achieve with the deformation. So just press transfer and finish and bring that back in. If we just navigate around, we can see some of the areas where we have sag into the floor, and some of the areas which seem to have a bit of a bulge or a raised area. So we could use all of these model lines now to deform the shape, or we could just use some. So in the first instance then, let's just select all of these model lines, and we're just going to click finish, and we're going to deform the shape based on those lines. Obviously there's a large number of intersections there, so we're going to end up with about 756 specific coordinates that are going to be used to deform this. So let's have a look at this result now. So that's killed off the surface analysis result, that's fine. So just navigate around. Obviously that is a large number of points to use to deform something like a floor. However, we can see it has actually obviously changed the geometry of the floor itself. So probably best would be to export less model lines, probably larger centres, or to focus on specific areas where we know we have issues. So what I'm going to do in this instance now, I'm just going to go and hide off the floor itself just for a minute, and then I'm going to just delete some of these model lines so we can just use a few different points or a few different lines to work with our FARO deformation tool. So I'm just deleting some of these areas now, so we can use these 5 lines. I'm just going to bring that floor back in because I'm going to need it to using the deformation tool. So we'll unhide that, And now if we just navigate around slightly and go to the deform shape tool, select that floor, and then I'm just going to pick these 5 model lines. I'm going to click finish. Now you can see we've got a slightly more manageable result. So we still have individual points around through those model lines that are being used to deform the shape, but it's a little bit more of a manageable result. So if we were going to hand this model over to a client now, we'd probably need to clean it up a little bit. So if we select one of these construction points, you can see they're pinned elements. So to delete one, we do need to unpin it and press the delete key, and these protocol points are similar. We need to unpin them before we can delete them. What we can do is we can take out protocol points en masse using the cleanup tool. But first, what we're probably going to need to do is just select all instances of the construction points themselves, and what we're going to do is we're going to convert those just to protocol points. So we're just dealing with protocol points. We'll do the same now with the scan positions, just convert them all to, just select everything in the project and convert them to protocol points. This is going to mean that when we run our cleanup tool, which is in the top right hand corner of the screen, we have a lot of options here, but specifically we're dealing with protocol points, so we need to make sure remove all protocol points is selected, and we're going to click OK. This is going to give us some information about how we could get this information back if we wanted to, and then we've also got a list of items that will be removed. So we've got 1073 protocol points that have now been removed. So now if we zoom in, we can see we've got a much tidier model, and all of the information we've created in terms of topo surface and deformed shapes and things is still intact.